Example 6, find the integral of sine squared 3x cosine 3x dx. So, think of this integral written this way, sine 3x squared cosine 3x dx. So, we're going to let u equal sine 3x. So du dx is going to be cosine 3x times 3. Or du equals 3 cosine 3x dx. So notice, let's make this sine 3x, let's make that u, so this will be u squared. And then cosine 3x dx, let's make this 3 cosine 3x dx, and since I put this 3 here, I have to multiply 1/3 out in front, so it's actually 1. So then I got the integral, I got 1/3 the integral u squared 3 cosine 3x dx, that's equal to du. And now I can integrate this, so this would be 1/3, the antiderivative would be u cubed divided by 3 plus c, and then this would be u cubed divided by 9 plus c, and then I can substitute u back in, so this will be sine of 3x cubed all over 9 plus c. Let's look at example 7. There's a few of these here. So we're either going to let this one be u or this one be u. So it's really trial and error. I'm going to let e to the x plus x be u, because when I take the derivative of u with respect to x, the derivative of e to the x is e to the x, and the derivative of x is 1. So du equals e to the x plus 1 dx, which gives me this piece of the integral here. So e to the x plus x, that's u. E to the x plus 1 dx, that's going to be du. So the antiderivative would be u squared over 2 plus c, where u is e to the x plus x squared divided by 2 plus c. Alright, let's look at c again. I'm either going to let this function be u, or underneath the square root here, I'm going to let that be u. I'm going to let x cubed minus 2 be u, because when I take the derivative of u with respect to x, this would be 3x squared, where that would be 0. So du equals 3x squared dx. So now I can substitute. This will become du. This guy will become u. So I'll have the square root of u, or u to the 1/2 power, du. And then when I take the antiderivative, it'll be u to the 3/2 times 2/3 plus c, where u is x cubed minus 2 to the 3/2 power divided by 3 plus c. Alright, part D, I'm going to let this part of the function equal u. Again, you're pretty much always looking for an f of g of x, a function being plugged into another function, a composition of functions. And the function that is inside of the function, the g of x, of f of g of x, is what you're going to make equal to u or g of x. So then when we take the derivative of u with respect to x, this is going to equal negative 4x dx, which that's going to be my du. Oops. That's going to be du. The bottom's going to be u squared. So I can think of this as being the integral of u to the negative second du. When I take the integral, I'm going to get u to the negative first divided by negative 1, or negative, plus c. So this will be negative u, which is 1 minus 2x squared to the negative first, plus c. I'm going to skip this one. It's so similar to this one up here, but easier. Let's look at this one. So, okay, this is a great problem here because now we have limits of integration. All of the other ones, it was a indefinite integral, where this is a definite integral, where we have our lower limit and we have our upper limit. Okay? So right now, this integral, what this really means is the lower limit, x is equal to 0, and x is equal to 1. This is x times x squared plus 1 cubed dx. Okay, so we're going to do u substitution. I'm going to let u equal x squared plus 1. So du, the derivative of u with respect to x, is going to equal 2x. Thus, du is equal to 2x dx. Okay, so if I'm going to substitute everything in here in terms of u to figure these out in terms of u as well. So notice when x equals 1, u equals 1 squared plus 1, so that's going to equal 2. And when x equals 0, u equals 0 squared plus 1 equals 1. So now I have my limits of integration. Okay, u will now equal 1 here for my lower limit. My upper limit, u will equal 2. Let's put a 2 here. So I have 2x dx, and then multiply this by 1/2. So this will be 1/2 here. This and this becomes my du, and the x squared plus 1, that's u cubed. So now I have this, and now I can find the antiderivative. So the antiderivative would be u to the 4th divided by 4. And we're going to integrate this from 1 to 2, or evaluate this. This would be u to the 4th over 8 from 1 to 2. When you put 2 in here, this will be 2 to the 4th power over 8 minus 1 to the 4th power divided by 8. 2 to the 4th power would be 2 times 2 times 2 times 2. This is going to be 16 over 8 minus 1 over 8. So this is going to be 15 over 8.